I will start. I will share the screen. Oh, before that, I will start my recording. Please let me know if you are able to see the screen. Hello. Are you being able to see the screen?
Yes, able to see the screen.
Okay. Actually, once the screen displays on my terminal, then I do not see this group. So you can just speak out. Okay. Don't if you are raising your hands or showing some emoticon or putting some chat, I will not be able to see it. But anyway, that's good. We can start from here. So the previous day, what we have, and is my audio audible? I mean, am I audible?
Yes.
Okay, great. So the last day we had stopped over here. We have actually discussed about this thing. We have discussed the entire AWS global infrastructure, availability zones, regions, and edge locations. Okay, so basically the entire world is being covered by AWS data centers by placing their data centers in each and every corner of the world. In India, there are 4, and the fifth one is coming up. And one data center has a huge capability. So in US, there are I think there are more than 7 or 8 data centers covering, because US is a big area to cover. Okay, and also the availability zones under each region, there will be availability zones. So under each VPC, as you said, that the regions are marked with at least one VPC, default VPC. Okay. Oh, let me open the marker. No, the pen. So that day we have discussed about the VPC. So there will be VPCs with each region, one default VPC. So if there are, say, I'm just giving a value that if there are 27 regions, there will be at least 27 VPCs, one each for each of the region. Virtual private cloud. Under that virtual private cloud, there will be subnets under each availability zone. So availability zone, let's say in India, the availability zones, so in India, there will be one VPC, and with this, there is, so in one region, let's say in Chennai, or say in Hyderabad, whatever it is, or maybe I'm taking Ohio. Under Ohio region, there is one VPC default, and then Ohio region will be divided into several availability zones, and there are 6 availability zones, AZs under Ohio, and each availability zone will have several subnets. The subnets by default generally will be 3 by default, but then you can increase them. Okay, and each subnet can hold 2 to the power of 32 servers. Can you see the capacity? Big servers, 2 to the power of 32. Each subnet can hold. So you can restrict the VPC of that. So VPC is generally 2 to the power of 64 maximum. It's a huge number. And also you can add up VPC. It is not that this is the default. So you can keep on adding VPCs. If you have a large organization and you have your own dedicated VPC, you do not go by the default VPC. You create your own VPC, and under that you can restrict the number of servers or the devices that will be attached to this VPC. So this is the network setup, and that is for the better governance. Better governance. Why do you divide the entire globe into countries and countries into states and states into districts and districts into towns, subdivisions, divisions, subdivisions, so many. So better, the more you make your things modular, the better is the control, better is the administration. That is the whole essence behind why they have done this sort of a structuring. Is that clear? But now this is the network and the infrastructure. Okay. But then there are 3 types of services available. These are all services. These are all, APIs or services that are available as from Amazon Web Services and from Amazon AWS. So basically, as a DevOps engineer, we are interested with the foundation services and management and administration services. As a DevOps guy, we must learn these 2 things. This one, and the DevOps guys and solution architect, cloud solution architect or cloud architects must know at least these 2 parts. And if you want to certify as a developer under the cloud, cloud developer. So you are an application developer, but you are working on a cloud. So you need to know all these services. Okay, developer or maybe a cloud architect. But it is not necessary for a cloud architect to know the details about this, but it is good, always good. At least if you need to get a certification of a cloud architect, you will face the questions from the application platform services as well. But if you are trying to be a solution architect, DevOps engineer, and with a very good knowledge on cloud, you must know the foundation services, management services, administration services. Clear? Any questions? Please let me know. Now, in this cloud and the foundation services, we need to have a very good idea of Amazon EC2 and maybe some idea on auto scaling. So what is EC2? Any idea? Anyone having any idea of EC2? EC2 is Elastic Cloud Compute. There are 2 C's. Cloud compute. Elastic. And we have explained why elastic. It can auto scale up, auto scale down. So it's an elastic property. But this is basically a virtual server. A server hosted on the cloud over a cloud service called compute service. Clear? This is a server. I do not have, my account is a bit frozen for the time being because I have not paid my last bill with Amazon. So my account is not activated, but I forgot basically. So I will clear up the bill. My account will be activated, and maybe next week I will. And of course, if I have to carry on with my DevOps internship sessions, I need to have my account activated. That I will do by next week. So I am not being able to show you how we create a EC2. That was a part of my agenda to show you, but I found my account is blocked. But anyway, I will do it next week. Storage. Now, storage is one of the very, very important functions or services of Amazon or cloud. Because if you are not very aware of how to store your data, very, very important thing is to store the data, and you must know these services pretty well. Amazon S3, simple storage service, S3. So the Amazon has a tendency to abbreviate. Okay, so they will not go, or the acronym, they will not go by the full name. So simple storage service is S3, and it is one of the world's most popular services. Even if you are not going for the whole of the cloud services as a SaaS, but you can use few of the services, not all, not needed. As I told you, Amazon or these cloud services are beneficial because you can hire the services and pay for that part only. You do not need to, if you are a cloud client, a client of AWS, that does not mean that you have to give AWS a bill of a fixed bill. No, your bill will vary based on what are the services. You may have opted for everything, but you are using only few things. That's all. You do not have to give any rentals for a sort of a postpaid billing. Okay, no rentals. So whatever actual usage, so pay as you go. So if you have opted for this storage, but you are not using the storage, then it's no, you do not have to pay anything. So S3 is one of the most important. So many developers, in fact, all developers will have to have a good knowledge on. You may ask, if you have said that developer will be learning about application platform services. Yes, but to handle S3 or to store the code, the Java code or whatever code you have written, you need to know how to store it over Amazon S3. So a developer needs also to understand this particular service pretty well. Okay. So app developer, so the developer having a certificate on as a cloud developer will have to face questions on storage and database. Maybe not on too much on EC2 or net or compute or networking or identity and access management. All these things are not needed, but at least he should be having a knowledge on S3. Amazon EBS, Elastic Block Service. It is sort of a hard disk, optical disk, like SSD. Solid state device, optical device. Okay. So, but this EBS is quite fantastic. It is like when you go for this, you have to pay a fixed amount. Here it is not fixed. It is again elastic. So it varies. The price will vary according to your usage. AWS storage gateway is a big storage. If it is organizational storage for individuals like us, for a developer or anyone using ordinary cloud users will not be very much aware of this particular service because they do not need it. But an organization like a big organization like IBM, okay, they will need to, they have huge data to be stored. So in that case, when the storage is like petabytes, you go for AWS storage gateway. It's a interesting, very interesting service. Very useful service, very popular service. I'm not going to the details because the scope is out, as somebody was asking, can we have like details, the live project or capstone project? No, because here those we do when we do our job ready training, the full course, which is of around 70 to 80 hours, 2 hours per day from Monday to in fact, I generally take 2.5 hours per day, per session per day for 5 days a week. So that is almost a 2 months course. There you should be covering each and every aspect. I'm not saying 2 months only on cloud. It is DevOps. 8 weeks full, where we cover around 10 to 11 sessions on Amazon. So 10 to 11 sessions means you multiply it by 11. Okay, this much of hours is quite good enough for getting a very, very good knowledge on cloud. And most of the training will be covering 70% of hands-on, that is practicals, and 30% is your theory. Anyway, so the database knowledge is very important, because if you are interested in some database handling, let's say somebody, like we had an experience of a DBA. I was a DBA. Okay, let's say I am a DBA and I want to use my experience, but now on the cloud. So I have to be aware of these services provided by Amazon, RDS, relational database services. The DynamoDB. DynamoDB is your NoSQL database. Have you heard NoSQL databases? So this is a purely SQL database. SQL means structured query language database, RDS, relational. Have you heard RDBMS? Like Oracle, Sybase, Ingress. So many databases are there. From MS SQL Server from Microsoft. So many database service, or you have MySQL, which is a very popular. Then PostgreSQL is a very popular. These are all RDBMSs, relational database, which is governed with SQL. Queries are through SQLs. But here, DynamoDB is like NoSQL. NoSQL. So NoSQL, sorry. Can you name one NoSQL database? Anyone? If you have a very popular database, is there?
MongoDB.
Yes, very good. MongoDB. It's a very, very popular. That means you are not guided with any particular fixed level of a structure of a schema. So there are no fixed schema. Everything is variable. So you can dynamically keep on adding columns to your table. There is no concept of table at all, because table is a two-dimensional or three-dimensional matrix. But here there is no dimension. It is a flexible. It will take your data as per your requirement and without maintaining any shape. And DynamoDB is very, very useful in your serverless data manipulations or data processing transactions. Okay, so with serverless processing comes NoSQL. There is a simple DB, there is an elastic, like you have Redis. Okay, so elastic cache means all the memory in the database. Memory in a database, or database in a memory, sorry. Database in memory is temporary, but it is very, very fast for transactional data processing, real-time data processing. This is very, very fast. For batch data processing, you cannot have elastic cache. You need to have RDS or DynamoDB. Anyway, these are the database concepts, but these are implemented. You do not need to be a DBA. DBA has a lot of knowledge in database management, but you can be an ordinary guy. Yes, you have some knowledge on database, But if your database is on cloud managed by AWS, like either Amazon RDS or Amazon DynamoDB, SimpleDB or Elastic Cache, it is 80% of it, or not even 80%, 85 to 90% of it is managed by AWS. So you have to manage only 15 to 20%, 10%. You will just have to have a knowledge of 15 to 10%, 10 to 15% of database. That's all. The rest will be handled by AWS. So it makes your life easier, and I mean, you do not need to have sleepless nights. Most of the things are getting done by AWS, managed beautifully in the background. Coming to networking. Okay, this is absolute must for any cloud engineer or a DevOps engineer to understand or to work on cloud. You have to have a good foundational knowledge on VPC, virtual private cloud, elastic load balancing, ELB. These we covered during our course. Amazon Route 53 and AWS Direct Connect is not that much important, but you have to be absolutely good on Amazon VPC. Otherwise, you will not be able to create your EC2s, and you have to have knowledge on this. You may or may not have a good knowledge on ELB, but you see, gaining the knowledge is very, very easy because most of the things are handled by cloud itself. You have to have a basic knowledge. That's all. Then it's Amazon Route 53 is like a, Big Daddy. Have you heard the term or the name of Big Daddy? They are the service providers for you to give your domain domain access. So you will create your DNS, domain name services, through this service of Amazon. Like the other service provider is Big Daddy, and there is others as well, big names. We will cover that during our Kubernetes session. Now, coming to this application platform services, as I told you, this is absolutely for developers and cloud architects. Content distribution, Amazon CloudFront. They need to know. They need to know a very good knowledge on how messaging is done over the cloud. Cloud search, like you have petabytes of data. How will you search it? Or in not only data, any information over the cloud, you need to have some, like the Google engine. But similar sort of a engine will be there as a service for the developers to use this search function or the search service as Amazon Cloud Search. Distributed computing. This is a very, very latest trend. You cannot do it in silo or in a centralized computing. Nowadays, your company is distributed all over the world, your company offices. So whatever you develop over the cloud has to be a distributed computing. So you use the elastic map reduce as very important. Amazon SWF. And here you learn the Lambda functions. Okay. Libraries and SDKs. You have the libraries for Java, PHP, Python, Ruby, .NET, and many more languages. So this the entire library is available over cloud as a service. So all the services are available. You do not have to purchase. You have to go for application platform services like libraries and SDKs from hire the services of Amazon. Coming to web interface. So now everything that you do as a cloud administrator is through the Amazon Management Console. I cannot show you because as I told you, I have locked my account. So, but it's the very graphical interface through which you will administer everyone whether it's you are administering the users or storage or EC2s or network VPCs or elastic load, whatever the services you can administer over graphically using AWS Management Console. Similarly is the identity and access management called IAM, very, very popular service. So all this federated IAM users, or rather you for the security and the services that you give it to each and every user on cloud is through IAM service. Identity and access management. So you are giving the access or access privilege to each and every user. So a payroll guy, a person who is in the payroll or accounts department or finance department will not have access to the HR services. Right? Similarly, HR guy with this sort of a role, access role, will not be able to have any access to the accounts guys. But all are working on the cloud on the same account. Okay, so you will be given your own account and privileges. So a developer will have its access to Amazon AWS, this service, MapReduce. But a HR guy, what will it do with this MapReduce or AWS or Lambda functions? They will not be able to get an access to all these things. So because the access privilege has been given in such a manner that they are locked out of their own domain itself. Okay, is that clear? Any question? And you can do it very easily. And lots of features are there. And deployment and automation. So I have so much of ease nowadays. Earlier, say around 15 years back, to deploy a simple service or a simple application over simple application, you will have nightmares. You need to go for a downtime. Nowadays, customers don't give any downtime. No need. You have all these beautiful services with you, and you can automate your deployment. You can apply, you can develop huge critical applications and with so many functions, but it will be easier for you to deploy and safely to deploy, and very much with integration and everything. You can use this service. You can use this Elastic Beanstalk, a fantastic service. AWS Elastic Beanstalk. And also Cloud Formation. In our job ready training, we do a lot of this, lot of all these things. This one, and we do not, of course, go for Elastic Beanstalk because it is we are not coming from an application background. Okay, let's say a DevOps engineer is not having much knowledge on coding and application development. So this particular service of basically no need. Yeah, you can learn Elastic Beanstalk, but maybe few DevOps guys will be asked to deploy an application. Yes, your developer, along with your developer, you will be using this Elastic Beanstalk. You will be called for deployment because you are a very good guy on a deployment. You know certain tools. Right now, you may not have. You have just started your code, your thing. So once you learn Docker, Kubernetes, you are master in getting deployments. And on top of it, if you know Elastic Beanstalk, so you can take the help of AWS service to deploy any application, whether it's a mission critical application or a simple application. It can be a monolithic application, single layer application, or it can be a microservice application. Very complex applications. You can deploy easily with your knowledge of Docker, Kubernetes, along with Elastic Beanstalk. Any question? Cloud formation. Again, this is another tool or a service from this one where you can provision. We will learn this provisioning as well. This how to provision any service or any infrastructure over the cloud using cloud formation. It is very simple. And for monitoring, this is mostly for the operations guy. So you are working as an in the operations department of a company, of a service-based company. So and on the cloud. So you must be knowing Amazon CloudWatch if your company has gone for AWS. Okay. So you may be knowing certain tools, as I told you earlier in the DevOps sessions. There are a few very good tools on monitoring. Can you name one if you have attended those sessions, earlier sessions? At least one. The DevOps tool. This is a cloud tool. What is the DevOps tool for monitoring? A very good DevOps tool. Anyone? So basically, you have a very good tool called Nagios, Prometheus, Splunk. Okay, we have discussed all these tools earlier. But you combine this with CloudWatch, it will give a fantastic monitoring tool advantage. Because after all, you are putting this Nagios on the AWS and try to use best of both the worlds. That will make your monitoring very, very sound and formidable. Any questions so far? Can I proceed to the next screen? So the types of cloud computing. I will not go through so many definitions, but I will use this diagram. So you will know there are 4 types of platforms, or rather infrastructure. Okay. From cloud, you get the 3 types to be used with the cloud as a service. So IaaS, PaaS, and SaaS. Infrastructure as a service, platform as a service, and software as a service. It is the entire solution that you get from the cloud. So this is some say maybe 60-40. 60-40. This is 80-20, and this is 100-0. And this is 0-100. Okay. There are no cloud services when you say that I am using an infrastructure on premise. That is, your company is having their individual place of holding all the things together, maybe a data center of the company. You have your own data center where you are hosting your networking, storage, servers, virtualization, operating system, middleware, runtime, data, and applications. Everything, all the blue ones are managed by you. You manage. So whenever there is a question, interview question, what is on-premise and how does it differ from any of the cloud managed services? You say that it is 0 versus 100. So that means you have to manage all the services yourself. And that means you means your company. So you have to employ the networking engineers, for monitoring or managing the networking. You have to have your storage guys, because these are very domain specific activity. You cannot have a general guy managing everything. You cannot. It is not possible. So you have specific engineers for storage, servers, virtualization, okay, operating system, middleware, runtime, data. So there will be a database administrator, DBAs, not a developer. Developer cannot manage the data as good as what a DBA can do. So everywhere, so there this is a development team, development, testing, design team, and so application team, solution architect. Okay, but here there is all the people are from the company, or they can hire, give it to some other third party. So maybe this is managed by HP. The storage may be managed by IBM. Servers, depends on which servers you have taken from which vendor. So maybe you have servers from Dell. So these OEM vendors are managing your thing. These are very capital investment intensive, CapEx. And here starts the OpEx. So OpEx means operational expenses. Maybe these are all capital expended expenses. And this is, and also it will having the name, because there will be always someone who is going to maintain you over the year, because anything can happen any day, anytime. So you must have dedicated engineers, resident engineers, to solve those issues. So it's a very cost intensive solution. Now, coming to the infrastructure as a service, here you see these blue ones are still with you. What are them? The operating system, middleware, runtime, data, applications are managed by you. But the lower levels, which are physical layer, okay, like the virtualization, servers, storage, networking, you have given to AWS, maybe. These servers, these services are managed by. So when you have a setup like this, where 60% of your services are managed by the third-party vendor or the cloud vendor, it is called infrastructure as a service. So definitions, you can go by the definitions, but definitions maybe you are not going to get it very clear. But when you go by this diagram, it makes it very clear. So the blue ones, applications, data, runtime, you do not want to give away your applications to be managed by the third party. So you started with this infrastructure as a service with AWS. So AWS will manage whatever is there under these four heads. So you can 100% rely on them. You just pay a nominal. So the maintenance cost of this will be reduced by almost like 10 times. Cost reduction for the company, because Amazon will charge quite less than the OEMs. OEMs are original equipment manufacturers. So one vendor is managing all the four layers. And now, after 1 year, you have got really a good return on investment, because these services used to take a lot of cost. Now it has been reduced like 10 times, and it was managed so peacefully and without any complaints from the client that you are very happy. Then your management thought, okay, why not we also give 3 more things: the OS, the middleware, and the runtime. along with the existing virtualization server, storage, network. So you are gone for 80% of your services with Amazon. This type of a setup is called platform as a service, PaaS. Again, it has reduced the cost by 10 times. And the management is very happy with the way this have, because they are experts. This AWS is an expert to manage all these things. So you have given the OS middleware runtime. So what is the difference between IaaS and PaaS? You will say that PaaS will also take care, apart from virtualization, server, storage, and networking, it will take care of the OS, management of the OS, middleware, and the runtime. But you are still having a control of your applications and of course the data, because see, ultimately a company is very, very concerned about the security and the privacy of the data. So, and that privacy and security is managed through the applications. Okay, so these two areas will still be with your company. They will not part with that. And that setup is called PaaS. Platform is almost the entire platform has been given to AWS to manage. Here it was not the entire platform, it is only the infrastructure. This is called infrastructure. And this infrastructure plus a part of your software, or this is part of OS is the software, middleware is the software, runtime is the software. So this part is, along with the infrastructure, makes the platform. You have given the entire platform for management. So it is platform as a service. And finally, and then you are very happy with the return on investment as well as client satisfaction service. See, CSA rating or CSAT is very high. It has become very high. Customer survey, acceptance, and whatever. Okay, so that survey has really gone very high, and you have been rated very high as a very good service company. Now, with this track sheet, with this particular credentials, Amazon has been awarded with the entire thing. Now the applications and data is also managed by AWS. So this sort of a setup is called SaaS. So can you now understand, if anybody asks you about the difference between SaaS, PaaS, and IaaS? Any question? Because many people get confused. They use the term, but they do not know what they are speaking about. They often use the term IaaS, PaaS, SaaS, but they don't know what actually that means. Now, from today, you have come to know about this thing. Is that fine? Any questions? So as I was saying, you need to know about the EC2. It is the virtual server. Virtual server. Why virtual? Because after all, cloud is virtual. You cannot see it. You cannot touch it. You cannot feel it. You cannot smell it. It is virtual. So anything is hosted over cloud is also virtual. So this is a virtual server. A server is actually there somewhere in some data center in any part of the world, but you cannot see it, touch it, and you do not need to. So that is why it is called virtual server or EC2, Elastic Can you say the two C's? Elastic Cloud Compute. Okay, two C's. It is nothing but a virtual server. EC2 provides remote operations of virtual machines, VM, on Amazon's infrastructure. So can anybody tell me how this EC2 is created on where final unit or where the EC2 will be created? If I give you like this, VPC cloud. Okay, so this is one region. Let's say this is Ohio. Ohio is one state in US. Okay, so there will be at least one default VPC. So I have under the VPC the availability zone. So Ohio will have 6 availability zones. AZ1, AZ2, AZ3, AZ4, AZ5, AZ6. Okay. And again, let's say I'm doing only one AZ, and there will be, what is this called? This the structure. This, what are these called? Anyone? We have discussed this the other day. Each of the availability zone, each of the region will have a nomenclature, a name. Okay, it doesn't matter. But what are these called? These are the network elements. These are all network elements, VPC. What is this, the last network element called?
Subnets.
Yeah, fantastic. Subnet. Maybe subnet 1. You can name any subnet. Subnet 1, subnet 2, subnet 3. Each of these subnets can hold 2 to the power of 32 max machines, devices. One of them is the EC2. So EC2 will be placed over here or created over in this subnet. You can have 1, you can have 1,000 scattered over all your subnets, but it will be in this particular availability zone under this region or under this VPC. So more or less the structure is clear to you. So you are creating a server in say Ohio. Ohio will have a name of the region. So US East 1 or 2. So that way. Okay. And the subnet availability zone will have the similar nomenclature. So basically, you are not creating your EC2 on the cloud on the VPC itself. No, you are not creating it on the availability zone. No, but in the subnet that you have created with each of the availability zone. So here is your server that you have created. You have created your server over here. And from you are in Mumbai of India. Over the cloud infrastructure, you can access any one of your servers anytime without any latency. Quick. Without even you knowing how much distance it has covered. from Mumbai to Ohio and a particular subnet and a particular data center. It has gone and fetched or accessed this particular server within fraction of seconds. And you thought if the data center was in Mumbai itself, so how fast that access will be, isn't it? So you try to make your data centers in the closer proximity of your users. So maybe the company is Amazon or your Flipkart, hosted somewhere in US. Okay, the main application and the main server, main domain. But maybe your Flipkart users are maximum in India. So you have Amazon. What they will do, the company will try to have a data center, or rather not data center, the servers located over for the Indian users, Indian customers of Flipkart over here in this region. So more or less, is it clear? So similarly, Amazon machine images, what are they? Can you have a server if you have got your laptop? Let's say I'm talking about a laptop. Laptop is a machine. Can you operate that machine without what? You have got your laptop. Oh, sorry. You have got your laptop. What is essential thing that you need to have without which this laptop will not run?
Operating system.
Sorry.
Operating system.
Did you say operating system?
Yes.
Correct. Without an operating system like say Windows, Mac, Linux, without any one of them, your operating system or your machine is a dumb machine. Otherwise, you cannot. Similarly, when you create your EC2 instance, it is called an EC2 instance, a server called EC2. You also need an AMI, Amazon Machine Image. It is basically when we learn Docker, we will understand what is images. Okay, we will learn that. Basically, you can think that the entire software package has been packaged under one container. So that container is holding that image, Amazon Machine Image, whether it's Linux or Windows or Mac. Are you getting me? So when you create a EC2 instance, you cannot create without 5 essential things. You cannot create a server without having these 5 essentials. Can anybody tell me at least 1 or 2 or 3 or 4 or 5? At least 1.
Key pair.
Which one?
I said key pair.
I cannot hear you actually. Can you spell it?
I said key pair. Key.
Oh, key pair. Very good. Fantastic. Key pair. Now, this key pair is, we will discuss that in our actual course, but then just for the time being, this is very important part. That means you have to get an authentication. You have to be authorized to access your server. That is one very important part. Key pair. Yes. Encrypted key pair. Yes, very good. What is the second one? Without which you cannot have a server. Create a server.
AMI.
Yeah, fantastic. AMI. Without an operating system, how can you go and create your server? Your server cannot be created without an operating system, and that is called AMI. Very good. Anyone with the third one?
Memory or RAM?
Memory. So it is
Security group.
very good. So this is the storage, right? You need to have a storage. Without a storage, your server cannot work. So this is the like the SSD. I told you SSD. So it is elastic block storage. Four. What did you say?
Security group.
Very good. Security group is the fundamental. Like you have a firewall. Everything is about the security because something is virtual and you do not want to get that system compromised of its security things. So the security group is a sort of firewall that is a mandatory part, the essential, without which you cannot create your. And while you create your security group or assign your security group, you have already mentioned your VPC. Without a VPC, a security group cannot be created. A firewall cannot be created without a VPC. And therefore, so going by that earlier design, that VPC is the place or the region where you are creating your server, isn't it? By mentioning the security group along with the VPC, you are actually mentioning your region, whether it's Ohio. You are building your server in Ohio. Last but not the least.
RAM.
RAM is a sort of storage.
Okay.
So we have already taken care of that. And yes, the RAM is of course there, but it will be already when you create a server will have its internal memory, of course. You will say that you are purchasing 16 GB of internal memory, RAM. That comes with the server configuration. But this is an external storage, not external storage. It is internal, but it is sort of a hard disk. It has a huge capacity. What about the last one? Very, very important. See, we are missing one thing. You have mentioned the VPC, but did you mention the exact place where you are going to create? Where you are going to create the server? So that is comes. Sorry.
Region.
Can you spell it?
Subnet.
Exactly. If you do not mention the subnet, where this is the physical location, this is the data center. This is the data center where you are going to create your server. Isn't it? Yes. So all these 5 without which you cannot create your EC2. Is that fine? Any questions? I'm very happy that you answered all the questions. Elastic block storage is the same thing that we have mentioned earlier in that earlier that elastic block storage. There is storage. Okay. I'm not going through it again. Fine. EBS snapshots. Now, so when you create your storage, there is also a question of point in time snapshots. So you say like it's a data recovery. Whenever you, even in Windows or even in your laptops, there is a point in time recovery. So then in that is called a snapshot. Similarly, with Amazon provides you a service called EBS snapshots. You do not have to do much thing. You just have to configure. You have to take the services. So it is like a backup and restore of the essential so that your OS can boot up. So something has gone wrong with the OS. You are not being able to boot up the machine. Bootstrapping. OS bootstrapping, something is wrong and your machine, your server cannot be made on. So you can use the last snapshot that used was the healthy snapshot. So it will be automatic. If you have already configured this thing, then AWS will call up this EBS snapshot and your current, this thing will be installed. So because that was already in backup, so you have backed it up in the data store S3, simple storage service of Amazon. So it is automatically in the background. So don't worry. So never, ever your server will fail to boot up. There will be never failure. So snapshots are incremental backups. Only the blocks on the device that have changed since your last snapshot will be saved. So it is not that every time you have to take a full backup. It is called an incremental backup of the essential services that were changed this time. So that change will always be backed up. And so therefore, every time you will get the full backup whenever there is something wrong. So if you have a device with 100 GBs of data, but only 5 GB of data has been changed since your last snapshot, only the 5 additional GBs of snapshot will be stored back to S3. So that is done very automatically within the Elastic Block Store devices. So the storage type is EBS, and with that comes another service called EBS snapshots. It's a fantastic feature. Simple storage service. Now, so with the developers, this particular service is the most important. S3 is a minimalistic data hosting service. So it's a sort of a hosting service. So it is there. You have to just call for it. You have to, it is on your on-demand storage. And the data will be retrieved on demand. So it is like a, it is there. If you are not using it, still it is there. Anytime you call this, and so it is a very, very important concept and very easy. It can be called from any applications. It can be called from Java. It can be called from PHP. It can be any of .NET, Python. So your application is hosted on, say, Azure Cloud. Some server on Azure Cloud, doesn't matter. But you have maintained an S3, Amazon S3 service, and you call it. So the application calls this service hosted on Amazon. So these are two clouds. This is the Azure Cloud. This is the Amazon Cloud. So your application is hosted over here. and your storage is hosted on S3 because this is very cost effective storage. So a person developing on this particular thing, they will store the data over on this, and it can be called anytime from this application. Storing data and downloading data in S3 are built separately. So storing the data is not an issue. It is very minimal cost. Okay, but when you download the data, there will be a cost which is more than storing the data. So storing is always good and cost effective. Then downloading. Downloading means you are downloading the data into your local system, but you can accessing a data which you have stored does not cost you anything. Only the time when you download the data, because it uses the resources of the cloud. So therefore it will be a bit costly. Then storing your data and accessing your data. Accessing is always free if you have stored. S3 only hosts dumb data, not dynamic data. It does not change unless you change it. You will change the data over from your application and store it. So till that point, this data is dumb. That means dumb means static. It is a static data. It is not dynamic. Okay, so S3 is appropriate for hosting static web pages. No server-side processing. It cannot be processed on the server side. It is a static web page. It's like say company's data. Like company's data, the first screen which comes up when there's the index page. So it shows welcome to IBM. CEO, Mr. X. CTO, Mr. Y or Mrs. Y. Okay, or Miss Y, whatever. So that way, this data is not going to change every day. Does it change? Do you have a CEO every day? So these are static data. The IBM name of the company doesn't change every day. So these type of pages are called static pages, which can be directly stored and accessed over S3. You can store large files, custom AMIs. It can be.
Change your button, no.
No, 12 Pro. We're change your device. I didn't
If you downgrade, no.
Hello, can you mute yourself, please?
At least you have been talking about 200 keys.
Sorry, can you mute yourself, please? So let's say there is a 1 TB of size of an AMI and you want to store it. Where will you store it? It's a huge data. You use S3. And whenever you require to access it, let's access it. So many images will be there. So although S3 is commonly used to store custom AMIs, the free usage tier does not provide enough S3 storage. So if you're not using free, if you have a paid usage tier, not free, because 1 year after you create an account in AWS, you are in the free tier. You are almost having 0 bills, even if you are using AWS services. But once you are over with one year, then it is not free, and then you can use big enough S3 storage. But at that time, you cannot have a very big storage, like 1 TB cannot be stored in one single file. Free 5 GB storage, 15 GB of data outgoing per month. So you can download 15 GB of data and you can store 5 GB of storage free. If you are in the free tier zone, but it is quite good enough. ELB, the load balancer, elastic load balancer service is solely for managing incoming network. So you have this okay, and you are hosting your application on a particular server over here, and there is another server as a standby server over here, or maybe your application is distributed. Your application is distributed in both of these servers. It is a distributed application. So same sort of data and application will be features, functions will be available at any point of time in both of the servers. Okay. So now there is a huge traffic coming in. And it is all going to the first server. Let's say I'm saying, and this is 1, this is 2. So every of the traffic is getting diverted to app 1, or rather server 1. At one point of time, what will happen, this server can crash, because let's say up to 10,000 customers or customer request per second, 10,000. Customer requests or simple requests per second is fine. It is coming all into this thing. Now it becomes 1 million requests, let's say during the Christmas, per second it is coming. This server does not have the capacity to handle that many requests. So what you do, you implement a load balancer over here. You have implemented a load balancer, and your customer request will interface with the load balancer directly. It will not go to the server. So the load balancer can automatically understand the health of the two servers, because they are distributed on the same network. Okay, so what will it do? If it is finding that it is crying for resources, it is overloaded, what will it do? It will divert the load to the second server. There is a round robin logic. Round robin algorithm. Implemented with the elastic load. There is also lots of other techniques. So it can easily understand. It will go a round trip every time, every few seconds. It will do a round trip between the servers. There can be 2. For the sake of example, I'm giving 2, but there can be hundreds of servers distributed. It's a big network, and they are all distributed. So same data is available in all of the servers, but at any point of time, a request is going to come and hit the load balancer. Load balancer will check the health of the servers, and then it will distribute, or rather redirect the traffic from one server to the other service as per the load. And this is done automatically by elastic load balancer. You do not have to worry, and you do not have to write a long program 1,000-line programs. Earlier, 25 years back or 20 years back, people used to write the logic of distribution of the traffic. So the application will hit this thing. So the traffic will hit this thing, hit this program, and that program will decide where it should go. But now the same thing, now it is available as a service. You do not have to do anything on your own. And this service is provided by AWS. Is that clear? Any question? So that is, it is continuation of the same discussion. So don't reinvent the wheel. That is the essential thing. You do not have to do anything. Use the ELB to do load balancing for you. So you can also use your dedicated EC2 instances with that function of distributing the load, but that will cost you much. Instead of, why don't you go for ELB? It is already a ready-made service available through AWS. So go for it, and you are saving a lot of money, and your functions or your effectiveness is also enhanced a lot of times. ELBs are an important part of achieving a scalable cloud service, but an ELB does not scale your available resources. Yes, it will not auto scale your servers. That is not the purpose. For that, you have the auto scaling services. So auto scaling of your services or of your resources is done by, say, auto scale feature of compute service. Right? Under compute service, there are two services. One is EC2 and the other one is auto scale. So this service will actually do the function of scaling your services. ELB does not auto scale your resources. Instead, an ELB allows you to efficiently use your available resources. You can distribute or efficiently use your resources. So as I told you, this is a DynamoDB. DynamoDB is what? DynamoDB is NoSQL database. Yeah, it is a NoSQL database. It is but fully managed by whom? By AWS. This is a service. So you are getting the MongoDB in form of DynamoDB on the cloud itself. So you are getting a beautiful service already available within the cloud. Automatically replicates your data synchronously across multiple availability zones. See, you can have your data distributed and replicated synchronously over the various availability zones within the AWS region. So a region will have several availability zones, and your data will be distributed in various servers under the subnets of each individual AWS. So this data can be synchronously be replicated between the zones and between the servers of that zones using DynamoDB. And this is highly available. It will not go down, and data durable. So the data is very highly reliable. Designed for extremely high throughput and low latencies for both reads and write. The most important block or the blockade or the hurdle of any database is the amount of reads and writes and the speed with which you can read and write over the database. That is the most of the database have that drawback. It can go slow, but this while this DynamoDB over the cloud is designed for extremely high throughput. So your throughput is very high and very low latency. Ability to scale to extremely large data sets while maintaining predictable performance. So it does not compromise on the performance while it can manage large data sets. Any question? Similarly is the case of Relational Database Service, RDS, which is an SQL database. Native access to the database is provided by SQL. So you cannot use any other language but other than structured query language. Structured query language. Because these are relational database, it maintains a schema. It maintains, let's say this is a table. Table is one schema. Okay. So you need to have a fixed structure, rows versus columns. So it is a 1, 2, 3, 4 columns and 1, 2, 3. So 3 into 4 metrics. So it is a fixed dimension. For this type of structures, you need structured query language to able to be access. So you are storing the data over here. These are all data. So now if you want to access this data, how will you do? You will use SQL. Ability to easily scale compute resources or storage capacity for each database. So it is dynamically because you have used the cloud service RDS. So it will dynamically expand your data, the instance, the table spaces and whatever is required in RDBMS. So your data is now hosting 10,000 or 10 GB of data. Now tomorrow or 1 year down the line, your data can grow to 1 TB. And the table was initially designed to hold up to 10 GB. But as and when the requirement grows up, it will also scale up dynamically in the background without your knowledge. That is the beauty. You don't have to do anything. You have to only configure your initial stages. You have to say that this is my configuration. So it can grow by 1 kilobyte per block each time in form of 1 kilobyte. So once you have given this mathematics to when you configure your database, then it will always keep on expanding 1 kilobyte per block. And that way, one day, when even if your 1 TB requirement from 10 GB is there, it will not crash. It will never crash. So RDS can be managed from the management console. As I said, there is a graphical console through which you can manage your database. Each DB instance will run until termination, which occurs when you issue an API call to delete the data. So yeah, of course, if you want to delete the entire database instance, then only this database instance will be down or destroyed. Until you do that, this DB is up and running for you. Maintained by who is maintaining this? It is up and running for you 24/7 and into 365 days. Into how many years you want? 10 years. Okay. It will never be down. But so who is doing that? Who is managing in the behind the scenes? if I may ask? Are you managing? No, you have made the database up. You are putting in the data every day, every day, every day. You are not worried who is managing and maintaining those data. It is AWS, this service, AWS RDS, because you have gone for this service. Okay. Basically, there are people, they are database engineers, highly paid by Amazon, who is maintaining all the databases. AWS is not paying them. Actually, the clients are paying them because clients have been using this database and paying AWS. In return, AWS is paying this database DBAs. That's how business happens. And AWS makes a big money. Of course, they are supposed to make a money because it is their system. You are using their service. Any question? Amazon VPC. I have already described about what is a subnet, what is an AZ, availability zone. So basically, Amazon Virtual Private Cloud, Amazon VPC gives you full control of your virtual working. Otherwise, how will you work on a cloud? You have to have your individual VPC. Without a VPC, you cannot build your organizational infrastructure. So you see, these are instances. So this is one EC2 instance. One EC2 instance. In another availability zone. So this is in the maybe the same subnet or maybe separate two subnets. There are two servers. Okay, but in the availability zone. One, availability zone 2. So they can interact between the availability zones of the same region. So there is a cross connection. You can access, synchronize the data, replicate your data over all the servers scattered on in AZ1 and AZ2. And here you see there is a different region. So let's say this is Ohio and this is San Francisco, or better say New Jersey. These two regions under US, they are separate two regions having your separate VPCs, isn't it? Again, this VPC will have its availability zone 1, availability zone. So there is a cross link, but there is no cross connection. But you can make also, you can have that connection between the two regions as well. So let's say your head office is in Ohio and your branch office is in New Jersey. So in the same organization, they need to have a cross link between the two regions. Yes, it is possible. So fantastic design. Do you agree? Now, as I was saying, that AWS Elastic Beanstalk, where it comes under? It comes under administration. And the more specific term is what? What you want to do with this particular service? Just few moments back, we have discussed that there is a service on the top layer. Deployment. Yes. So you are not a developer. Yes, but you are going to work. See, DevOps guys are not specific to any team. DevOps itself is a team of that organization. They work closely with the developers, the testing team, and the operations team for each and every project. Are you getting me? But they are not specifically a tester, neither they are operations guy, neither they are developers, nor they are designers, nor they are solution architects, nor they are project managers. They are a different breed. DevOps, and there is a huge demand. for this particular skill. So you are working with the developer has developed an application. Okay. Now this application has to be deployed into one infrastructure. Now this is a containerized application. Maybe this entire application is contained within one image. This is the container, and you have the one application image. Now this is one single unit. Say, let's say there are hundreds of Java programs within one image. Fine, no issues. It is one single jar file, maybe. Java application archive file. Or maybe a web application, Java web application, WAR. But the problem is, yes, you are not deploying each and individual hundreds of files over there. That is not that will be a chaos. It is easier to deploy one single file, one jar file, one WAR file, or one .NET file. Okay. Now, how can you automate that? This needs to be deployed over, say, several machines, several servers. This is maybe a testing server. This is a pre-production server. There can be production servers, there can be development servers, so many servers can be there. There can be 2 or 3 pre-production servers. There can be 2 or 3 test servers. But what you need to do, you have to deploy in smart way such that it can be deployed in one go. What you do, you take the help of a service from AWS called Elastic Beanstalk. So what you do, you upload your application with the environment configuration, whatever it is, all within that container. Okay, you upload them into the service called Elastic Beanstalk, and the rest you leave it on the Elastic Beanstalk. Elastic Beanstalk has been configured within AWS to distribute anything coming in onto it to the various servers available, and will implement the load balancer so that this application can be easily distributed and the traffic can be distributed between the servers through the Elastic Load Balancer. So the entire setup can be done within minutes. The deployment will be done within minutes with the help of Elastic Beanstalk. Isn't it fantastic? If you had to do it manually, you will take maybe days. And that too, it may not work. But here there is no fault. Everything will be taken care by the Elastic Beanstalk. Deploy and scale also the scaling. That means, say there is a huge traffic and you are not being able to only manage between the 2 distributed servers. Okay, you need the third one. Elastic Beanstalk will take care to implement another EC2 and deploy that application over it. So you are doing the automatically scaling up the web application. Upload and deploy web applications in a simplified, fast way. Focus on writing code instead of provisioning and managing the infrastructure. So a developer will focus on writing a code, then only the quality of the code will go up. If the developer has also to manage the deployment and the infrastructure and the distribution and this and that of the infrastructure, network can fail, this and that can happen, storage can fail. So it's too much of a load on a developer. He may not miss the vital points of what the customer wants. So writing the code should be the main focus of the developer instead of provisioning. Let it be handled by Beanstalk. Select and retain full control of the optional AWS resources for powering your applications. Use adjustable settings to scale your application for handling peaks in traffic. So you can just use the configuration settings available within the beanstalk. Just say what you want. Why Elastic Beanstalk? Elastic Beanstalk is a service for deploying and scaling web applications and services. Upload your code and Elastic Beanstalk automatically handles the deployment. From capacity provisioning, load balancing, and auto scaling to application health monitoring. The monitoring of the health of the application is also done. So what else do you need? Okay, so all this provisioning will be done through the Elastic Beanstalk. You just have to put application code based on the requirement as you have configured on the Elastic Beanstalk. It will do all these things. Isn't it nice? These are really good tools to have. Again, for your provisioning. So in terms, just go to the previous one. So you are provisioning this instances, this cloud S3 buckets for storage. You may have, you want to implement this Cloud Watch. So, and the Cloud Formation. So what will happen? Cloud Formation will create all these things, but who will call this? Elastic Beanstalk will call the Cloud Formation, which is again AWS service. So Cloud Formation in turn will create this Elastic Load Balancer, EC2 instances, S3 buckets, whatever, the infrastructure will be created. So Cloud Formation is nothing but a provisioning tool of AWS. Lets you model, provision, and manage AWS and third-party resources by treating infrastructure as a code. So you can build your infrastructure with an infrastructure as a code service of cloud called of AWS called Cloud Formation. So are you getting the terms quite clear? So Cloud Formation is not going to function like AWS Beanstalk. AWS Beanstalk is for deployment. And Cloud Formation is for provisioning. Provisioning means creation of infrastructure. So infrastructure as a service. Like we will learn Terraform. Terraform is a third-party tool from HashiCorp. We will learn that. We will discuss on that in one of our sessions. So then we will learn that this can provision things similarly to what you can do it over the cloud without using Terraform. But Terraform is very good. We will learn that. So whatever you want to do, the code infrastructure from the scratch. So you use AWS Cloud Formation, CF, Cloud Formation to code your infrastructure. Amazon S3, you can create you can load your code, the one that you have created over the Cloud Formation manually, or you can use it through console and use the Cloud Formation, and the Cloud Formation will create you the infrastructure according to the template that you have created, okay, and stored. So when you execute this template of Cloud Formation, you are going to create your S3 buckets or EC2 instances or VPC or subnet, anything you name it. You can also create what? E-pair. E-pair is also an object. You can create the infrastructure. You can create that. You can create your EBS, Elastic Blocks service, storage, sorry. Anything you name it, you can create with the template that you can do with CloudFormation. You can code it directly. That is why it is called infrastructure as a code. So identity access management is your you creating the resources. Okay, so here you have created your resource through, as I told you, this is a very important service. IAM, Identity Access Management, Identity and Access Management. So you are creating the identity as a user. You are giving an access to, say, let's say a Lambda function. He is a developer working on the cloud. Okay, he wants to use the Lambda function for using serverless transactions. So you have to give an access to this Lambda function of AWS. How is access to Lambda create function determined? So you cannot do it without a IAM. If you try to do it, it will get you an error. But you have to use IAM to give this user a create function that is a function within Lambda. So that you are giving a Lambda access to this particular user. Therefore, the error will be gone. You have given it perfectly using IAM. And this is the statement that you have generated. We will learn that actually in the main course, how to do it. But if you do not want to do it manually, you can do it entirely graphically using what? If you want to create the user, give him the access. How? Without writing a single line of code like this. It will be generated in the background. Who will help you? There is another service. How can you create an IAM user and assign him all the resources? So you are creating, you are using the IAM service, but how do you do it graphically? You are not writing a code. You will use the AWS console. This is another service, as you know, on the topmost layer, administration service. So AWS, through the graphical interface, AWS console, you can create whatever you want to do. IAM is also one service. So you can access all the services through your AWS console if you have got the proper privilege. When you create an account with a root user is the super user. Okay, and a super user will have access to all the resources and all the services in AWS. But when you create a particular user which is non-root user, you will be giving access to the resources, and you can do it graphically using AWS console. Is that clear? Any question? Is anybody there? I wonder.
Yeah, here, sir.
Okay. So we have covered the basic things in AWS. Okay, I will try to get my account corrected, and I can take one session on AWS hands-on. Okay, but I cannot promise because still my account is not in a working condition. Let it be corrected. I think it should be corrected, but you see, once you give a request, it can take a bit of time with them. Anyway, I will try to contact the AWS support team and get my account corrected. Once it is done, I will take one more session on AWS, though I was supposed to have only one session for AWS, but this is today is the second one, and maybe I will end up with another one. So it doesn't matter because everything is in our control. It is up to us to to keep on learning. Okay, no issues. Thank you very much for all your time and patience. We will end the session over here today. It has been a long session. I know, understand. It's a Saturday morning or afternoon or evening according to your time zone, but really it is really a good effort that you have put in. I will stop the recording here. We will meet again next Saturday.
Thank you, sir.
Thank you very much. So we can end the session.
Yes, sir.
Okay, thank you. Okay, thank you all. I'm leaving the session. See you in the next Saturday again.